what we are just going to telling, right? So easy to understand, right? So now I'm just going to start. So alternator, right? So yesterday itself we have started alternator, right? So alternator in the sense it's going to generate AC, right? So generate AC, right? So this is called a generator. Alternative power is going to generate it. That's why it's called alternator, right? So the same way, so in DC generator, so what are the things we have discussed, right? Around 80% of parts will be same as in alternator also. So in DC generator, what we have discussed, we just need to go with small recall. The entire thing will be applicable here also. North pole, south pole, and there is a rotor, right? I'm just going to right. So I'm just going to connect it. I'm just going to have a brush slip ring. I'm just getting a output over here plus minus, right? I'm just going to this is the setup. So north pole to flux lines is moving, right? So this is called my stator. This is called my rotor. I'm just going to rotate manually. So rotate பண்ண எனக்கு power supply எனக்கு rectify கிடைச்சது with the help rectify ஆச்சு with the help of slip ring as well as brush, right? So the same thing in alternate is also going to apply, right? So how it's going to be, right? So this is one thing I'm just going to discuss you right now, right? So என்ன பண்ண போறோம்னு பாருங்க. So we'll have two options, right? So this is called my stator, this is called my rotor, right? So anyway, my ultimate aim is that I need to create d phi by dt. So this is my ultimate aim, right? So I need to go with that d phi by dt. By only by using this d phi by dt only, I'm just going to induced EMF over this coil, right? So you know output, then I'm just going to take it as output. So ultimate aim is the d phi by dt. So how the d phi by dt is going to be created? By using mechanical rotation, right? So by using mechanical rotation only, I'm just able to get d phi by dt. Or one more way, so I could have instead of rotating this rotor part, I'm just going to keep it constant, right? I'm just going to keep it constant. Now I'm just moving this north pole south, but I'm just going to moving this one. I'm just going to keep as this coil as a stator, right? So I'm just going to make it as this one rotor, and I'm just going to make it as this one as stator. So ரெண்டு சேம் தான்ப்பா, ரைட்? ஸோ இதை நான் ரொட்டேட் பண்றேன், இப்படி ரொட்டேட் பண்றேன். எனிவே டிஃபைபிலிட்டி கிடைக்கும். ஸோ ஒன் மோர் கேஸ்ல இதை ஸ்டாண்ட் பை வச்சுட்டு இது என்ன பண்ண போறோம், நார்த் போல் சவுத் போல் ஐம் ஜஸ்ட் கோயிங் டு ரொட்டேட்டிங். அப்போ என்ன ஆகும், அகைன் இந்த ஃப்ளக்ஸ் லைன் இஸ் மூவிங் வித் ரெஸ்பெக்ட் டு டைம். ஸோ அப்போ என்ன ஆகும், அகைன் டிஃபைபிலிட்டி இஸ் நோ சேஞ்சிங். ஸோ டெஃபினட்டா எனக்கு என்ன கிடைக்கும், எனக்கு இங்க அவுட்புட் எடுக்கிறது நம்ம என்ன பண்ண போறேன், இந்த நார்த் போல் சவுத் போல் இருந்து நான் பவர் சப்ளை எடுத்துனா திஸ் இஸ் கால்ட் மை ஆல்டர்னேட்டர். We'll see in detail, right? So there is a two way of creating d phi by dt. One is now rotating this coil, or maybe rotating this north pole south pole. So both are same. Anyway, d phi by dt is now getting. So this is a concept in alternator, right? So we'll see, right? So this is a concept, right? So anyway, I'm just going to create a d phi by dt, right? So now I'm just going to have, right? Right, I'm just going to place so both way we could able to do, right? So I'm just going to have a rotating part will be like this, right? I'm just going to make a winding, right? So I'm just going to apply DC power supply over here. So I'm just going to apply DC power supply. So DC power supply in the sense with the help of brush and carbon, right? So I'm just going to have a two brush arrangement, brush, right? So I'm just going to rotate this, right? So I'm just going to able to rotate. So in the rotation, I'm just going to give us a steam turbine, right? Right, steam turbine or maybe a mechanical rotation steam engine, right? So அப்போ என்ன ஆகும், I'm just giving DC power supply over here plus minus. அப்போ என்ன ஆகும், definitely constant flux lines is going to be flowing in this coil, right? Constant flux lines, right? So for example 100 volt, right? So or maybe a 50 volt, whatever ever needed, right? So for example I'm just giving a 50 voltage for understanding purpose. So definitely I'll just, so this there is a steady state current is now, that's called DC current is now flowing. Let's see, DC current, right? So have meaning, so DC current, DC power, right, is now flowing. Upper there is a 50 voltage, for example 50 flux lines, for example I'm telling. So 50 voltage, right? So 50 ampere current for let's maybe for understanding purpose only. So 50 amps la nama kudukka poradilla, right? For understanding purpose I'm just giving 2 ampere current, right? So for this purpose, around 50 flux lines is now getting 50 flux lines is going to be generated for understanding purpose, right? It's not exact calculation. For understanding purpose, 50 volt I'm applying, 2 ampere current is now flowing, 50 flux lines is also be flowing. Up and there is a 50 flux lines is going to be built up, right? So 50 flux lines is going to be built up around this coil, right? So in the flux lines is not going to change any with respect to time. In the flux lines may change our it will be constant flux lines. I told that. So there is a steady state current that is called a direct current is flowing. So when the flux lines is not going to be boom groom like this, it's not going to move like this. So it only be kept constant, right? So because of 50 flux lines hold it's not changing itself, right? So there is no AC power supply, it's now constantly like this, right? Now I'm having a winding over here, right? Right, so I'm just winding like this, right? So I'm just winding like this. Now I'm just going to rotate this direction, right? See this coil, I'm just going to manually rotate this rotating part, right? I'm just going to connect a small lamp over here. In last mode we are just giving a power supply to this. Now we are just making as this as a magnet, this one is now rotating part. I am just getting a power supply from output, right? This is called DC generator la pathom. என்ன பண்ணும், இதே நார்த் போல் இது சவுத் போல் வச்சுட்டு ஃப்ளக்ஸ் லைன்ஸ் ஜென்ரேட் ஆகிட்டு போயிட்டு இருக்கும். இது என்ன பண்ண போறேன், ரொட்டேட் பண்ண போறேன். இதுலயும் காயில் இருக்க போது இந்த காயில் இஸ் நவ் சேஞ்சிங் வித் ரெஸ்பெக்ட் டைம் பிகாஸ் ரொட்டேட்டிங். அப்ப இதுல இஎம்எஃப் ஜென்ரேட் ஆச்சு, அதை நான் அவுட்புட் வெளியில எடுத்தேன். தட் இஸ் வாட் மை டிசி ஜெனரேட்டர். பட் இன் மை ஆல்டர்னேட்டர் வாட் ஐ எம் ஜஸ்ட் டூயிங், நல்லா வாட்ச் பண்ணி பாருங்க. I am just giving a DC power supply to this rotating part. I am just rotating now. நல்லா அண்டர்ஸ்டாண்ட் பண்ணிக்க, ரொம்ப ஈஸி தான், ரைட்? I am just giving a DC source, constant power supply, constant flux line is also going associated over here. I am just going to rotate it. So இங்கேயும் பவர் சப்ளை கொடுக்குறேன், அதையே ரொட்டேட் பண்ண வைக்கிறேன். This is called now my permanent magnet. Now it acts as a permanent magnet. You could say now these are called as permanent magnet, north south, right? Plus minus power supply கொடுக்குறேன், மேல plus கீழே minus. So மேல plus north pole, கீழே south pole வச்சுக்கலாம். This magnet is now rotating because of I am manually rotating this coil, this part, right? Now what is going to happen? இப்போ என்ன நடக்கும்னு நினைக்கிறீங்க? Anyone? That's the answer, final answer. That's easy. அவ்வளவுதான், முடிஞ்சது answer, right? Anyone? I'm just going to connect a lamp instead of input. I'm just going to connect a lamp. என்ன நடக்கும்னு நினைக்கிறீங்க? Anyone? I am just rotating this coil. I am also giving a power supply to this also. So now this act as a magnet, right? So north pole, south pole. But in the flux lines is not changing with respect to time because I am just giving a constant power supply. அப்ப என்ன நடக்கும்? See, in the space la north flux lines, see north flux lines will be fully connected with my this coil, right? So this end, for example, A side, this is my B side. இந்த சைடு பாருங்க, south flux lines will be fully attracted by this magnetic core. இங்கே பாத்தீங்கன்னா காப்பர் வைண்டிங் தான் இருக்கு. Now I'm just continuously this rotating பண்றேன். It is coupled with my this end. Now this also start to moving. அப்ப என்ன ஆகும், அடுத்த கேஸ்ல south இங்க வந்துரும். In the tumbles it will be now it will be moved into this direction. For example, I'm just going to write it on the other right side, right? So it could have rotating. Now we'll have 4 diagram, right? So now it's rotate பண்றேன், right? First case la pathina tumbles will be like this, right? See in this position. Second case la I'm just going to moving like this, right? So the tumbles will be because I'm rotating, right? So in the mari vandrum. Adutha case it will be now in vertical case. Adutha case it will be somewhat in horizontal. This is called full one revolution, right? So this is called full one revolution, right? So first case la north south mela irukku. So this is my first case. So north south. So I'm just going to rotate in my clockwise direction. So north will be here and south will be here. Further I'm just rotating. So south will be here, north will be here. Further I'm just rotating, north will be here, south will be here. Further full rotation, south will be here. First case, second case, third case, fourth case, fifth case. Totally one revolution is now happen, right? So இப்போ என்ன நடக்கணும் பாருங்க. So first case la my flux lines is now associated with my A. Second la B, right? அடுத்த கேஸ்ல north is fully இந்த பக்கம் போயிடுச்சு, south is இந்த பக்கம் வந்துச்சு. So there is no flux lines. இந்த கேஸ்ல பாத்தீங்கன்னா I'm just going to now rough it, right? இந்த கேஸ்ல என்ன நடக்கும், I'm just going to replace the second case. So I'm just going to now draw like this, right? Now இப்போ என்ன நடக்கும், right? Now it will be like this. இந்த மாதிரி தம்பிள்ஸ் மாறிடும். எனக்கு ஃப்ளக்ஸ் லைன்ஸ் இங்க தான் இருக்கும், ரைட்? அப்போ இங்க வெரி மினிமம் ஃப்ளக்ஸ் லைன்ஸ் தான் இருக்கும், ரைட்? அப்போ எனக்கு இங்க there is no flux lines is now contact with my A side as well as B side, ரைட்? அப்போ என்ன அர்த்தம், எனக்கு now இனிஷியலா n இங்க இருக்கிறப்ப ஃப்ளக்ஸ் லைன்ஸ் ஃபுல்லா இருந்திருக்கும். பட் இந்த கேஸ்ல ஃப்ளக்ஸ் லைன்ஸ் எப்படி இருக்கும், it now started to decreasing, ரைட்? அடுத்த கேஸ்ல பாருங்க, the first caseல flux lines, for example I'm just drawing like this. First caseல flux lines will be maximum, right? So நான் rotate பண்ற flux line is now getting decreasing. ஏன்னா இந்த direction போடுச்சு. So இந்த direction வரப்ப flux lines, this is called my north, south side மேல வந்துச்சு, north side கீழ வந்துச்சு. It shows that in opposite sideல ஃபுல்லா இருக்கும். அடுத்த கேஸ்ல again 0 வந்திருக்கும், அடுத்த கேஸ்ல ஃபுல்லா இருக்கும், அடுத்த கேஸ்ல 0 இருக்கும், அடுத்த கேஸ்ல ஃபுல்லா இருக்கும். So now there is a alternative EMF is going to be built up across this coil. Am I correct? Any doubt in this? Because I am just changing this manually. So the change பண்றதுனால the flux line is going to affect this coil, this both coil, because I am just rotating. But இதுல induce ஆகிற flux lines constant flux lines தான், because I am just giving a constant power supply. So I am just rotating with the help of steam engine, or maybe steam, or maybe a windmill, right? I am just rotating. அப்ப என்ன ஆகும், the flux lines north pole south pole is now changing. ஸோ அப்போ ஒரு செகண்ட்ல நார்த் இருக்கும், நார்த் 0 ஆகும், அப்புறம் சவுத் பாருங்க, இந்த கேஸ்ல சவுத் சாரி இந்த கேஸ்ல நார்த் ஃபுல்லா அசோசியேட் இருக்கு, அடுத்த கேஸ்ல நார்த் இஸ் நவ் டிக்ரீசிங், நார்த்தோட ஃப்ளக்ஸ் லைன்ஸ் இஸ் அசோசியேட்டட் வித் திஸ் காயில் இஸ் டிக்ரீசிங். பட் அடுத்த கேஸ்ல பாருங்க, சவுத் இஸ் நவ் அப்ரோச்சிங், சவுத் சைட் இஸ் அப்ரோச்சிங் டு மை திஸ் ஏ சைட். அப்ப என்ன ஆகும், சவுத் சைடோட ஃப்ளக்ஸ் லைன்ஸ் இன்க்ரீஸ் ஆகும், அடுத்த கேஸ்ல சவுத் சைட் மேக்ஸிமம் ஆயிடும். தட்ஸ் வை ஐ டோல்ட் தட் சவுத் சைட் ஃபுல்லா மேக்ஸிமம் ஆயிடும், இந்த இடம் வந்துடும். அண்ட் தென் south side again is now moving, அப்ப south side is now moving on opposite direction. அப்ப south side ஆன்சர் வந்துட்டு reduce ஆகும், 0 வந்துரும். again north is approaching, north ஓட வேல்யூ இன்க்ரீஸ் ஆகுது. so now there is a alternative is called up and down flux is going to be built it up. So due to this there is a alternative EMF is going to be built it upon this across this two winding coil. So this is why a single phase AC power supply could be drawn like this, right? So this is called one phase, right? Single phase power supply could be drawn. So இதெல்லாம் டவுட் இருக்குங்களா? இது புரிஞ்சதுன்னா entire thing alternate easy. So next I'm just going to draw one more diagram. So உங்களுக்கு ஏதாவது டவுட் இருக்கு அதுல? கொஞ்சம் லிட்டில் பிட் நான் இன்னும் டெப்தா எலக்ட்ரான் போட்டோ அப்பெல்லாம் போல. I'm just going to give you that overall idea, right? Alternator. இதுல டவுட் இருக்குங்களா? This is called one phase power supply is now generated. Any doubt in this up to anyone? Phase say yes or no? உங்களுக்கு okay. நான் இப்ப என்ன பண்றேன் பாருங்க. Now I'm just going to rearrange this diagram. So anyone just have a small photo. Now I'm just going to rearrange this diagram, right? So before 1 second, right? 1 second. So this is called cycle, right? So this is called half cycle and one full cycle. So this is called one cycle, right? So we already discussed. This is called one half cycle, one positive cycle, one. This is called one total cycle, one cycle, right? So cycle in this time we'll call it as frequency. So frequency is equal to one time, that is called 60 seconds. How many cycles is now generating? In the 60 seconds, one cycle is now creating. That is called my frequency is now 1 by 60. So the frequency 60 is the time, so 60 seconds. Now we'll have a frequency, right? So that is called 1 hertz frequency, 1 hertz. So in a 1 second, 60 seconds, 1 hertz, right? So a frequency எப்படி இருக்கும்னா, so f is equal to 1 by t. So if t is now increasing, sorry, the relation between time as well as frequency. So if I'm just going to increase this frequency, in the sense I'm just going to increasing this rotation speed. If you're just going to increase the rotational speed, you could able to have much frequency. Increase பண்ண frequency increase ஆயிட்டே வரும், right? So frequency is now n is equal to, is directly proportional to f. So if you're directly increasing your speed of rotation, you could able to increase the frequency, right? So this is one more relation. Now you could have a snap. கொஞ்சம் குயிக்கா photo எடுத்துருங்க. If we want to increase your frequency, you need to increase your speed. That's all, right? 1 second, I'm just going to rearrange this diagram a little bit, right? So this is a single phase power supply generation. Make it fast. ஸோ எல்லா கான்செப்ட் டிசி ஜென்ரேட்டர்ல பார்த்ததே தான். பட் லிட்டில் ஸ்மால் சேஞ்சஸ் தான் நடந்திருக்கு. என்ன பண்ணியிருக்கேன், அங்கே இதை நான் பவர் சப்ளை கொடுத்துட்டு இது ஸ்டேட்டரா வச்சுட்டு இது ரொட்டேட் பண்ணுவேன், பவர் சப்ளை வெளியே எடுத்திருப்பேன். இங்க பார்த்தீங்கன்னா என்ன பண்றேன், இதுக்கே பவர் சப்ளை கொடுத்து இதையே ரொட்டேட் பண்ண வைக்கிறேன். எனிவே இது கான்ஸ்டன்ட் ஃப்ளக்ஸ் லைன்ஸ், கான்ஸ்டன்ட் பவர். ஸோ கான்ஸ்டன்ட் ஃப்ளக்ஸ் லைன்ஸ் நான் ரொட்டேட் பண்றேன். அப்போ ஒரு செகண்ட் நார்த், ஒரு செகண்ட் சவுத், இஸ் ஆல்சோ ரொட்டேட்டிங் பிகாஸ் அப்போ இந்த ஃப்ளக்ஸ் லைன்ஸ் இஸ் அசோசியேட்டிங் வித் திஸ் காயில் இஸ் ஆல்சோ கெட்டிங் சேஞ்ச்ட். Due to this north pole south pole is changing, definitely of a dφ by dt is occurring. So now we'll have a alternative EMF is going to build upon my uh, status side. So other than output right, I'm just going to now replace into this diagram into little bit like this, right? Now I'm just going to replace like this much. So I'm just going to draw like this. So this one type. So for example, this is not a exact straight line. Speak is not right. So இதுதான் டெஸ்ட்லா ரெடி பண்ணது, ரைட். we are just going to discuss now. So நிறைய ஸ்டோரிஸ் இருக்கு, பட் it will be a good story, but time இல்லாதனால I'm just going to skip many things, right? So I'm just going to wind it. How the Tesla is now framed, right? So Edison, how they just faced நிறைய இருக்கு, but the time is now not up to high much time. So now this is one end. Now I'm just placing three coils in a case. I'm just going to place three coil in 120 degree apart, right? So this is what my first case. So 120 degree apart la na vikkiren. So stator பார்க்கறதுல 360 degree இருக்குல்ல total cylinder. I'm just splitting into three. So now we'll have 120 degree apart. So one more 120 na. So 90 will be R Y. That's why I'm just using green. So this is what my 90 degree, right? 120 somewhat here. 90, 120 it will be somewhat here இருக்குமா, right? So I'm just going to rough it here. So 90 degree இங்க இருக்கும். So 0, 0 degree, and here 90 degree, right? 120 will be somewhat here, right? Somewhat here. Now I am just going to place one more coil. So somewhat it will be getting changed actually. So 120 degree it will be like this, right? So எனக்கு ஸ்கேல் இல்லாதனால நீட்டா வரல, but you need to draw neat manner in your exam time, right? So it will be 120 degree. Scale and then I could also draw in a neat manner. So 120 degree, right? So this is what my one more winding. I'm just going to draw the same red color or maybe green color. Concept understood பண்ணிட்டீங்கன்னா very easy. Concept is much important, right? அதை நான் எடுத்துட்டு வரேன், அந்த காயிலை எடுத்துட்டு வரேன். I'm just going to jump it actually. There is no direct connection. Jump பண்ணி எடுத்துட்டு வரேன். Winding. This is my one more output. One more, right? So 90 degree, 120, and one more 240, right? So each and 360 degree, I'm just going to 360 degree, I'm just going to split it into three categories. So 90, 0, 0 degree, and 120 degree, and one more 120%, 240. So this is what my 180, this is 180 degree, and this is 270, I guess, right? So this is my 270 degree. Up 120 will be in mid of this thing, right? So this is what I 120 degree mid of, right? So I'm just going to replace this coil. So 240 somewhat in middle இருக்கும். So the winding will be like this, right? So 240 will be 180, and 270, 240 will be in mid, right? So I'm just using one more different color. So R, A, B, blue color I'm just using. Somewhat 120 it will be somewhat this area, right? So 188 degree, so 240, right? So it will be somewhat here. Scale illa, so 240. So now 240, somewhat it will be look like this, right? So now we'll have one more coil. ஸோ இந்த வைண்டிங் எடுத்துகிட்டு போகிறேன், ஜம்ப் பண்ணி தான் கொண்டு போகிறேன். நான் எங்கேயுமே இன்னொரு ஃபேஸ் கூட பவர் சப்ளை நான் கனெக்ட் பண்ணல. ஸோ இண்டிவிஜுவல் ஃபேஸ் சப்ளை, right? So this one. Now, three different winding, three different pole pair, right? So this is called one pole pair at 0 degree, and one more pole green color, it's called B phase. We'll call it as we'll just name it as R phase, Y phase, and B phase. We name it as RYB. So R dash, Y dash, and B dash, right? We call it like this, right? So now R one pole pair, that is called one set of winding, and Y is now 120 degree apart. This is called one more pole pair winding, and 120 degree apart, 240 degree one more winding. This is called one pole pair. So one winding, two winding, and three winding. Total 360 stator part, right? So total 360 part, I'm just going to split it into 360. I'm just going to split it into, right? I'm just going to the black color winding கொஞ்சம் நான் கீழே draw பண்ணிக்கிறேன் for understanding purpose, உங்களுக்கு ஈஸியா இருக்குல்ல. Then I'm just going to draw like this, right? So for 360 degree outer case, I'm just going to winding like this, right? So three individual single pole winding, right? So இதுக்கு நடுவுல என்ன பண்ண போறேன், அந்த tumbles நான் place பண்ண போறேன். Now I'm just going to place the tumble, right? So I'm just going to place a tumble over here. For example, I'm just going to place it somewhat R face, right? So instead of R face, we'll go it to be, I could draw, and anyway, I'm just going to draw like this, right? So this rotating part we need to place it now, right? So this is my rotating part, somewhat tumbles shape. So anyway, I'm just going to play the animation. It will be very easy to understand, right? So anyway, but before into that, we need to understand what actually happening, right? So that's why I'm just planning, right? So here I'm just having a DC power source. You could imagine I couldn't able to draw a brush arrangement as well as a carbon arrangement over here, but you know, just imagine I'm just connecting this brush and slip ring arrangement over here, and then I'm just rotating this part, right? I'm also rotating this part. I'm just rotating in this part also, right? So imagine பண்ணிக்கோங்க, I'm just applying a DC source, and it as well as I'm just rotating, right? So with the help of brush and carbon brush and slip ring arrangements over here. So now DC power supply is also given. Just now how we'll have, right? I'm just going to have a output, right? So now maybe on the single phase power supply alternative on this layer. Now we need to find out, we are having three different types of winding, right? So we are having three different types of winding. How it will be look like this, we'll see, right? We'll see, right? So we'll have three individual winding 120 degree apart, right? Now see, in the case என்ன நடக்கும்னு பாருங்க, in the position la, right? So flux lines will be here, right? So flux lines will be here. It will be maximum. Shall I have north pole and south pole, right? If watch பண்ணீங்கன்னா எனக்கு பாத்தீங்கன்னா I'm just rotating like in clockwise direction. So I'm just going to rotate clockwise direction. So எனக்கு பாத்தீங்கன்னா B phase and Y is now nearby this flux lines. அப்ப என்ன ஆகும், நான் see இந்த பொசிஷன்ல நான் 90 டிகிரில இதுக்கு ஒரு ஹாஃப், இதுக்கு ஒரு ஹாஃபா ஸ்ப்ளிட் ஆயிருக்கு. Am I correct? Y phase is now half and B dash is somewhat half, right? I'm just creating R Y B phase totally, right? அப்ப RYB தனியா இண்டிவிஜுவலா வரைஞ்சுக்கிறேன். இந்த கேஸ்ல பாத்தீங்கன்னா Y phase it at maximum, right? So center positionல தான் இருக்கு. So not actually center position, it will be somewhat half position at positive side. North pole is now we'll call it as north pole positive. For understanding purpose, we'll call it as south pole is negative, right? For conduction purpose. So inga watch பண்ணீங்கன்னா, so Y phase for this rotation, if now Y is at maximum, half of maximum, so Y is somewhat here, right? It's now once the rotor is now going to rotate like this, definitely இது கூட associated reflex range is now releasing. So it moves to zero. That's why it moves to zero. So it now somewhat in positive half, but while rotating it losing its value in the position poiடுச்சுனா, now it leads to zero. That's why I write it here, and Y is now getting zero. And then இது எப்படி இருக்கு, it initially, so B is, that is called B dash, that is called B dash na in the x axis க்கு கீழ, right? So somewhat here. இது என்ன இருக்கும், இப்போ initially half plus rotation இருக்கு, right? So we'll have plus rotation, we'll call it as somewhat here. So it will be somewhat where could I say it will be maximum reach ஆக போகுது, right? It will be somewhat here, இங்க இருக்கு, right? It's moving to like this. So இப்போ இது என்ன ஆகும், இங்க இருக்கு, அடுத்த கேஸ்ல மேக்ஸிமம் ரீச் ஆயிடும். ஸோ சம்வாட் ஹியர் பாசிட்டிவ் ஹாப்ல இருக்கு, அடுத்த கேஸ்ல இந்த இடத்துக்கு மேக்ஸிமம் வந்துடும். ஸோ இந்த கேஸ்ல இப்படி இருக்கு, இந்த ரொட்டேஷன்ல இது இங்க வந்துடும், இந்த இது மேக்ஸிமம் ரீச் ஆயிடும். ஸோ லைக் திஸ். ஸோ அடுத்தது பார்த்தீங்கன்னா இது என்னவா இருக்கும், இப்போ சவுத் சைடு இது வில் பி இன் ஆர் டேஸ் ஒய் பி டேஸ். ஸோ இட் வில் பி நவ் it will be b dash, so it will be somewhat here. So எப்படி rotate ஆகும் பாருங்க, ஒரு half rotation காமிக்கிறேன். Now in this phase, so it will be going like this, it will be going like this, right? So it will be now continuing, it will be continuing, it will be sorry, it will be continuing like this. And then r phase பார்த்தீங்கன்னா அது initial stageல 0 இருந்திருக்கும், right? So இந்த பொசிஷன்ல பார்த்தீங்கன்னா r இதுக்கும் r that is called r dash very 0, right? So இது rotate ஆகுதுன்னா அப்புறம் கொஞ்சம் கழிச்சு ஸ்டார்ட் ஆகும் somewhat here. So 120 degree எல்லாமே 120 degree apart. So now it will be somewhat இங்க தான் ஸ்டார்ட் ஆகும். So இது பார்த்தீங்கன்னா இதுக்கும் I will say so every phases is have 120 degree phase difference. This also இங்க பாருங்க r பாத்தீங்கன்னா 240 டிகிரிக்கு அப்புறம் தான் இட்ஸ் now start to increasing, but y phase is 120 டிகிரிலே ஸ்டார்ட் ஆகுது, and then b பாத்தீங்கன்னா 0 டிகிரிலே ஸ்டார்ட் ஆயிடுது. so why it's now நம்ம previously பார்த்தோம் இல்லையா, single phase power supply is now generating, but in this case we are having 120 degree apart, right? So each and every phase is now 120 degree apart. r பாத்தீங்கன்னா let's see 240 டிகிரிக்கு அப்புறம் தான் ஸ்டார்ட் ஆகுது, y phase 120 டிகிரில, but b phase 0 degree. You could see 0 degree, 120, 240. So every these things will be started from 120 degree phase difference. The doubt irukla, the first one in the operation doubt illana, so you could have that this assembly is, it will be very easy. Now we'll going to mingle this r y b phase into a single diagram. So operational doubt iruka, whenever I'm just going to DC power supply over here, there is a constant flux line is going to be built it over here, and I'm just going to manually rotate this one. Definitely this flux lines is now moving because of I am rotating manually. So in the flux line is associated with these three outer body winding, it gets waving, right? So it gets changed actually. So change as a dphi by dt in every coil is also going to be changing. So over coil dphi by dt is changing, definitely over coil there is a EMF is going to be generated. So on the flux lines it will be in alternating nature because north pole south pole is changing. So that definitely each and every second is changing. So definitely positive negative is now it's inducing. So that's called we have a 110 degree phase difference, r y b moon three windings. So definitely three individual phase plays now winding. So three individual EMF is going to be built up in alternating nature because I'm rotating like this. So now and even just have photo, and I'm just going to draw a three phase power supply over here. This is what a exact diagram, exact working principle in major thermal plant, how it's running, right? So see, anyone just make a quick snap. So time வேற பயங்கர வேகமா போகுது, right? So make it fast.
Yes, sir.
Now I'm just going to erase it here. I'm just going to draw three individual power supply in a single line. This is called group எடுக்க போறேன். Now I'm just going to getting output from my state, that is called, right? So now so எப்படி சார் டிரா பண்றது கேட்கலாம். Now see there's a simple a technique is available, triangle based வரைவாங்க. So it will be very easy. So எப்படி டிரா பண்றீங்கன்னா, so just draw triangle shapes first. ஒரு triangle வரைஞ்சிருங்க, and then every triangle just make it as a curve. இந்த curve எல்லாம் join பண்ணிடுங்க. So this is a way of drawing three phase power supply. So each and every phase is now 120 degree phase difference. We just now we have discussed. Just draw like this. It will be very easy method, right? I'm just going to now draw draw a x-axis and y-axis, right? I'm just going to draw it like this. Little bit half of the above triangle, right? I'm just going to draw like this, right? Now you could have just remove this interconnection lines, right? Now I'm just going to draw a different color. So first of all r this one, right? I'm just going to draw r. So நீங்க நீட்டா draw பண்ணி நீட்டா வரும். This is called my r phase. starting with 0 for example, R phase. So need to drop an example, confuse right? R phase, and then Y phase is now little bit delayed by 120°. So or y instead of Y I'm using green. So instead of it's now lagging, right? So 120° lagging. So in the lag ஆகுது. It's now Y phase 120° lagging here, right? So Y axis பார்த்தீங்கன்னா கீழே தான் ஸ்டார்ட் ஆகுது, 120° lagging. Right, so this is what my Y phase 120° is now lagging with my R phase. Right, அடுத்து B பார்த்தீங்கன்னா that's called blue. It's now 240° lagging, somewhat behind that, right? So இங்கிருந்து ஸ்டார்ட் ஆயிருக்கும். So it should be 240 in the sense here. I'm just going to draw like this. So here it's now here. Right, so this is my B phase. So individual draw பண்ணீங்கன்னா அப்படி இருக்கும். We are having a 3-phase power supply like this, right? So now I'm just going to draw this one. So this is what my entire 3-phase, how it's built on my alternator, right? So this is RYB. So individual பார்த்தோம், நான் group draw பண்ணா இப்படி தான் draw பண்ண முடியும், right? So each and every one is now 110° R, Y and B phase. So this is my R phase, Y phase and B phase. So these are the individual 3 single phase power supply is now generating and grouped together, and it will be traveled from along 3-phase power transmission line. So அதனால உங்களுக்கு transmission line எப்படி draw பண்ணிருப்பாங்கன்னா ஒரு pole இருக்குன்னா, right, transmission line பார்த்தீங்கன்னா 4 lines போகும், 1 2 3 4 போகும். நீங்க just go and visit a nearby power supply. So one line shows that R, one is B and is now neutral line, right? This is RYB. So each and every power supply that is called voltage is now changing around 120°. So 120° phase shift is now rotating. So this is how the AC power supply, that is called alternative power supply, that is called 3-phase AC power supply, is now drawn from my alternator, right? Any doubt in this up to this? So this is a working principle of alternator and how it's generating in how we are just getting in output side. ஸோ நல்லா வாட்ச் பண்ணிங்கன்னா தெரியும். ஸோ அந்த கேஸில் என்ன பண்ணியிருப்போம், டிசி ஜென்ரேட்டர் நல்லா அண்டர்ஸ்டுட் பண்ணிங்கன்னா லிட்டில் ஈஸியாக கிளாரிட்டி கிடைக்கும். ஸோ அந்த கேஸில் வி ஹாவ் கிவன் அ பவர் சப்ளை ஓவர் ஹியர். ஐம் ஜஸ்ட் கோயிங் டு ட்ரா சைமல்டேனியஸ்லி, ரெண்டு சேமாக ட்ரா பண்ணிடுறேன். வில் ஹேவ் பெட்டர் கிளாரிட்டி ஓவர் ஆல்டர்னேட்டர் as well as generator. I'm just going to simultaneously draw. So it will be very clarity இருக்கும், right? So this is what my first case where we have discussed, right? So இங்கே என்ன பண்ணியிருப்போம், I'm just going to make it as horizontal manner. It will be very easy to understand, right? So north pole, south pole, இங்கேயும் அதே மாதிரி தான், north pole, south pole in alternator, north pole, south pole, right? The same structures will be available, north, south, right? And then what we have done in a generator, right? So generator என்ன பண்ணணும், so we have given a power supply to this coil, right? So we are just given a power supply, right? So we are given power supply to this coil, right? So we are just given a power supply and we are make it as electromagnet, right? So we are just given a power supply and we are just make it as electromagnet. So electromagnet have run பண்ணிட்டு and we just placed a copper conductor loop and it is now connected with my end ring, that is called my slip ring, and I'm just rotating. I'm just getting a power supply from this terminal, right? So this is called my plus minus. I'm just getting. So this is what in a generator we have discussed. But inga enna pannom, just see we are getting a power supply. So nalla watch panni theri idhula enna pannom, idhileye idhe rotate panni idhileye power supply veliye eduthu d5 by dt is now getting here, right? But inga enna pandrom, there is a small difference, not big difference, right? It's very easy, right? So inga enna panna, I am just going to winding, adhe winding da, right? So adhe winding da, now I am just winding created, right? So winding created, now it should be there, winding create nature. Instead of giving power supply and we are make it as this electromagnet, I'm just simply winding it, right? I'm not giving any power supply to this part, right? I'm just simply keep it on empty, right? So keep it on safe. Now I'm just placing the same rotating part, right? So same slip ring, same brush arrangement. I'm instead of getting power supply, I'm feeding a power supply plus minus. I'm just giving a power supply and I'm rotating. The same rotation irukku, inge rotation irukku, right? So everything is same. Instead of getting a power supply from this side, I am just giving a power supply here on rotation. But power supply alternative and power supply. That's all. Both the same. I am just able to get a power supply load. Right? Anyway, we need to create a defibidity. That's all. So one either constant வச்சு this change பண்ணலாம் இல்லனா either constant வச்சு this change பண்ணலாம் இல்லனா இதை change பண்ணிட்டு rotate பண்ணலாம். Whatever maybe you just going to create defibidity. So this is what my alternator. This is what my generator. Right? So this is a small concept, better clarity, right? So any doubt in this? I'm just going to wind up this one. We are just moving into next one. Right? Any doubt in this? This is how the AC power supply could be generated from a machine. That is called, you could also called as AC generator. You could also called previously drop on the diagram. This is called my AC generator. Or maybe you could call it as alternator. So nothing wrong in it, right? So this is a power which could be drawn from my alternator machine. So this is what my output, right, from a alternator, right? So three phase power supply, which is each and every phase is now 120 degree apart. Say 120 degree apart, I'm just having a coil like 120 degree phase difference. I'm just placing that copper coil, right? So copper winding, I'm just placed about 120 degree. So it will be look like this, right? So 120 degree now. So I'm just placing 0 degree and 120 degree and 240. Somewhat I'm just placed coil over here, one more coil over here, one more coil over here. Now in between I'm just rotating my electromagnet, right? So I'm thumble side, my electromagnet is rotating. So the coil is now rotating, and that is called a DC power is now applied to these thumbles, and definitely it's act as electromagnet. So electromagnet has flux lines over this coil, and it's now rotating by using it with the help of turbine maybe. And the flux line is now associated with this 0 degree, 120 to 40 degrees changing. Definitely the EMF is also going to be generated on each and every coil with respect to 120 degree. So 120 degree, we are just placing that coil about 120 degree. That's why the flux lines will be generated like this, right? So this is output waveform which is drawn by from my alternator, right? So any doubt up to this? We're just going to move to next topic. Any doubt in this? So one more thing. So what is the frequency of this three-phase power supply? So you could have the question, right? So you could have the question. The frequency I already told it. So based upon this rotational speed, your frequency will be changing, right? So we are having now three poles. So three 120 different poles, right? So now, right? So we'll have a formula now. N is equal to F by P. That is called N directly proportional to F. But we are having a three pole pairs, totally 6 pole, right? So totally 6 poles, right? So 3 pole pair. So one pole now, one pole pair in the sense opposite as well as front end. So we'll have 3 pole pairs. So totally 6 poles. Either pole. Totally we are speaking pole pair, right? 3 pole pair. So now the frequency will be like this, right? So my induced frequency will be so number of poles, pole pairs, right? So by P. So how many poles will be there and how many speed is now rotating? So NF directly proportional to, and that is indirectly proportional to my pole pair. That is called my frequency. This is what a small a formula which is able to find out, right? So if for a single phase power supply, if it is a single phase power supply, F, that is called my N is equal to, that is called my F is equal to N and 60 second. It is called how many 1 by T. So this is called T. So 60 seconds later, I'm just going to how many rotations is happening. So now 60, it will become my numerator. So 60 N, right? It will be like this, right? So in three phase, we'll have a common notation F directly proportional to N of by P. Right? I'm just going to wind it somewhere here. So make it fast. We'll move into next topic. So this is what how the AC power three-phase power supply could be generated from an alternator, right? So with the help of three single-phase individual winding, individual pole pair at placed about 120 degree apart from each other, right? So we need to go with it. This is what alternator consists in working principle, right? We'll move into a motor side. This is called my alternator, right? So three-phase power supply. Even just have a photo, and there's a difference between generator and alternator, right? So here generator, you'll have alternator, right? You just make it fast. I've taken, right? Thank you. And now three supply anyway we have drawn. We have generated a three-phase power supply. It's quite interesting as well as a good topic, but we are just moving to need to fast it up because we need to complete entire syllabus, right? So it's I think I cleared everything, right? So I just told everything, no issues, and I'm just going to post video Okay, could have a recall. Now I'm just going to, now we have a three-phase power supply, right? I'm just going to apply this three-phase power supply to my one of my three-phase motor, right? So the motor is going to be convert three-phase power supply into mechanical rotational energy. These are things we have discussed in a DC motor. எப்படி பார்த்தோம்? So DC machine, right? So we have given a DC power, it's converted into mechanical output, right? So this is what we have called DC motor, right? The same way here we are just generated AC three-phase AC power supply. We have just now we have three-phase AC supply. Just now we have generated in the power supply. I'm just going to give into AC machine. AC machine. Definitely the three-phase power supply is now automatically converted into mechanical output. This is called AC motor, right? So this whole thing I have designed DC generator, right? DC motor. So we have generated a power supply from DC generator, and the generated power supply is given to my DC machine. This machine is now going to convert DC source power supply into mechanical output. That's why it's called a DC motor. That's the same thing. We are just now generated a three-phase AC power source. We are just going to apply the three-phase power supply into AC machine, right? This AC machine is now going to convert three-phase AC power supply into my mechanical rotation. This is called my AC motor, right? So we'll have three types of power supply. Just now we have discussed three-phase and three-phase and single phase. Single phase na ஒரே ஒரு waveform தான் இருக்கும். That is called my single phase neutral. My three-phase, right? So there is a group of three R, Y, B phase will be coming. So if you are using single phase power supply, then it will be called as single phase AC motor. If you are using three-phase AC motor, right? So this whole thing we are just going to discuss right now. So I'm just going to move with it now. By tomorrow class we are just going to see about single phase induction motor. Now in our hand we are having three phase supply. Just now we have 5 minutes before only we have discussed, right? So three phase AC power supply we have drawn from alternator. Now I'm just going to apply three phase power supply my two induction motor, right? So now we are just going to see about induction motor, right? So we are just going to moving into AC motor, right? So three phase AC motor working principle. Three-phase AC motor. We are just going to move with it. So in the motor slide, there will be two types of motor. One will be a scroll cage. We'll discuss later. Type of three-phase scroll cage AC motor. One is a slip ring induction motor. We'll see. These are the two types of three-phase AC motor will be available. One is a scroll cage motor. One will be slip ring. We'll discuss later. But once we just finish this construction working principle, right? Now the same three-phase power supply is now generated. Just now we have generated, and we are just going to feed this three-phase power supply into my stator side, right? I'm just going to draw this one. See, I'm just going to draw, because we are having a three-phase power supply. See, like this. I'm just going to draw once again, right? So R phase and Y phase is around somewhat 120-degree phase difference. Right, so you can draw with the triangle. So you could have the diagram with the triangle. So now it's now 120 degrees now up, 240 degrees now apart from this one. So these are my R, Y, B. So these are R, Y, and B. So these are the
நான் ஜாயின் பண்ணது வெறும் 4 பேர் தான். அதுதான் இப்போ நான் டீட்டெயில்ஸ் சொல்கிறேன் போயிரு. நான் ஜாயின் பண்ணது பார்த்தீங்கன்னா டிப்ளமோ பார்த்தீங்கன்னா சுந்தர்னு ஒருத்தன், சந்தோஷ்னு ஒருத்தன், அதுக்கப்புறம் இன்னும் 2 பேர் இருக்காங்க. அவங்க ஒர்க்கே பண்ணுறது கிடையாது. 2 பேர் தான் ஒர்க் பண்ணுறாங்களே.
anyone just யாரோ பேசிட்டு இருக்கீங்க, எங்க பேசிட்டு இருக்கான்னு தெரியல, வேற எங்கேயும் பேசிட்டு இருக்கான், ரைட்? அப்ப நான் பேசுறது எவனும் கேட்கல போல, ரைட்? ஓகே, எனிவே I'm just going to continue my class, right? So just be conscious in your class, right? It will be somewhat quite interesting as well as difficult class. Once you're just able to follow the like just now only you could able to understood, right? Otherwise we couldn't have a difficult, right? So it will be much difficult to understood. So கொஞ்சம் cooperate பண்ணிக்கோங்க, right? So now I'm just having a 0 degree ஒரு coil இருக்கு, right? I'm just going to place coil like this because I'm having a three-phase power source. This power supply I'm just going to apply into my AC motor, right? For the purpose I'm just going to place three different coil in 120-degree phase apart, right? Then only could able to go with that. So now I'm just having a one more coil over here. So each coil should be 120-degree apart. So time from the faster, right? So we'll have 120-degree apart from 3 coils. There is also 240 case, right? So I'm just going to draw three different windings. It should be three different winding will be in a 120 degree apart, right? So I'm just going to draw first case RYB. This is called my R phase, right? I'm just going to bring it over here. எந்த காயில intersect பண்ணல வாட்ச் பண்ணிக்கோங்க, right? So இதுக்கு இந்த காயில் இருக்கு இல்லையா, this R front end, R phase, R ஓட ending, R dash. இதுக்கு தான் என்ன பண்ண போறேன், R power supply கொடுக்க போறேன். That is called blue color இருக்குல்ல, that is called R phase. இந்த power supply இந்த காயில கூட நான் கனெக்ட் பண்ணிடுவேன். That is called my neutral end, phase neutral. And then second one 120 degree upright, right? So this is what my RY. This is my second, this is called my Y and Y phase. So என்ன பண்ண போறேன், இங்க நான் கொடுக்க போறேன். Now I'm just bringing outside. I'm just going to bring into jump பண்ணி தான் எடுக்கிறேன் பாருங்க. இந்த electrical contact கொடுக்கல, இன்னொரு coil, right? My output side. So RYB. So R dash Y dash. And then one more phase is coming. That is called my third phase, 240 degrees apart, right? So 240 degree apart. So அங்க என்ன பண்ணேன், இதுல இருந்து power supply எடுத்தேன், right? So outer side இருந்து power supply I'm just drawn it. But here I'm just giving a power supply to this outer part. This is what a difference, right? You could see, right? I'm just going to jump it over here, jump பண்ணிருக்கேன். I'm just going to wind it over here. I'm just getting output. That is called my B and B dash, three phase, right? So அப்ப என்ன பண்ண போறேன், இந்த dash எல்லாத்தையும் நான் கனெக்ட் பண்ணி ஷார்ட் பண்ண போறேன். So dash இருக்கு இல்லையா, that is called secondary ending of my every coil, right? So இது என்ன பண்ண போறேன், எடுத்துட்டு ஷார்ட் பண்ணிட்டு இது நியூட்ரல் கொடுத்தப்ப, that is called my neutral point. Remaining இருக்கு இல்லையா, so Y, right? And then R and then B, right? இதுக்கு தான் நான் பவர் சப்ளை கொடுக்குறேன் input, so right? So first terminal, sorry, R எங்க இருக்கு, this is my first terminal and second terminal, B is third terminal. இதுக்கு தான் நான் பவர் சப்ளை கொடுக்க போறேன். Remaining two endல என்ன பண்ண போறேன், கனெக்ட் பண்ணி நியூட்ரல் ஷார்ட் பண்ணி நியூட்ரல் ஜாயின் பண்ணி போறேன். அவ்வளவுதான், that's all. Now I am just going to, right? I am just going to now place a rotating part. That's called my rotor part. I am just, this is called my entire thing is now called rotor. Now I am just going to place, right? So this also 360 degree இருக்கணும். So sorry, 360 degree இருக்கணும். Now I'm just going to convert it into 120 degree apart. இங்க இருக்கிற மாதிரி நான் I'm just going to place 120 degree apart, right? So now, right? So this is called 120 degree apart from each pole, salient pole types. Salient pole is called projection, right? So now winding drop பண்றேன், drop பண்ணிட்டு, so short circuit பண்ணிட்டேன், right? So winding எடுத்துட்டு full short circuit பண்ணிட்டேன். It's a more important thing, right? Short circuit. So ஆரம்பிச்சிட்டு உள்ளே winding பண்ணிட்டேன். There is no power supply is given to my rotate part. So இதுக்கு முன்னாடி நம்ம DC மோட்டர்ஸ்ல பார்த்திருப்போம், we are just going to feed a power supply to this rotating part also in my DC motor. But when I AC motor, I am not going to give any power supply to this part. Only I am just going to wind a copper conductor and I just make this a closed path. That is called short circuit மட்டும் தான் பண்ண போறேன். I am not going to give any power supply. Now what is going to happen? Let's see. I am just giving a power supply to RYB. So here see, we'll see this is quite interesting as well as, right? So in the case la pathina, in the time, right? So R is now maximum. So in the time period la paranga, R is now maximum. So R is now maximum. That is called my R is now 0 degree, right? 0 degree. R is maximum. So it will be look the resultant fluxes, right? So definitely the current is flowing because of R phase, Y phase, everything is winded with my input power supply. Definitely I'm just going to allow the flow of current over here, right? So definitely there is a flux line is going to be generated. This will act as electromagnet. So the current pass பண்ண it will now act as electromagnet. So இதே மாதிரி இது electromagnet இருக்க போது, இந்த set electromagnet. So three different types of electromagnet is now going to be built it up. So the flux lines is going to be generated. அப்ப resultant overall flux lines மூணுமே electromagnet ஒர்க் ஆகும். இந்த R, இந்த Y, இந்த B. So three electromagnet is going to generate three different types of flux lines. But மூணுமே 120 degree phase difference ல create ஆகுது. But அப்ப resultant flux lines, that's overall output. Overall output flux lines எப்படி இருக்குன்னு பாருங்க இந்த டைம்ல. So R is maximum. So R is now placed in this direction. So R is maximum. So இந்த இடத்துல அதிகமா இருக்கும். So y pathina somewhat கீழ இருக்கு நெகட்டிவ்ல இருக்கு. So y will be in somewhat y. So and b also in negative. So x axisல பாருங்க, this is called my x axis. r மட்டும் தான் மேல maximum இருக்கு. இந்த டைம் பீரியட்ல y also கீழ இருக்கு, b also கீழ இருக்கு. So the resultant overall flux lines will be in my this direction. So இந்த y ல பாருங்க, அடுத்த instead of 120 டிகிரிக்கு அப்புறம் பாருங்க. So y is now maximum. Y எங்க இருக்கு, எனக்கு இங்க இருக்கு, right, இந்த directionல. So now maximum resultant will be here flux lines, and b pathina run somewhat here. So b will be in this case pathina b is now somewhat increasing. So b pathina enak eppadi irukku, in the direction irukku. So somewhat b is now decreasing, and r is also in my negative direction, right? So overall resultant flux will be in this direction. Now you could have that length of my arrow mark, and this b side la pathina now will have, now b is now in the direction irukku, b is somewhat in the direction irukku. So maximum resultant flux will be in this direction, and then on the second la parunga. So r is also negative, y is also negative, right? So this will be like this. அப்ப ஒவ்வொரு செகண்ட்லயும் பாத்தீங்கன்னா the resultant flux lines will be moving. So இந்த செகண்ட்ஸ்ல பாத்தீங்கன்னா the flux lines will be இப்படி இருக்கு. So அடுத்த 120 டிகிரில the flux lines is now moving somewhat, it's shifted to, it will be like this, right? So அடுத்த கேஸ்ல the flux lines is now 120 டிகிரி அப்புறம் shift ஆகுது. அடுத்த கேஸ்ல overall flux lines will be this time. So அப்ப என்ன ஆகும், the flux lines is now changing. So in the first கேஸ்ல r phase ஓட flux lines, the resultant overall flux lines ஓட force overall flux lines and the generated flux lines, it will be like this. So அடுத்த கேஸ்ல y the maximum reach ஆகுது. So the flux lines is, the overall flux lines is going to be moving this direction. So அடுத்த கேஸ்ல b is now making a full power supply. Now the generated flux lines will be moving like this. So அடுத்த கேஸ்ல நான் மறுபடியும் r in the direction வந்துரும். So now there is a flux lines, the resultant flux lines is moving in this fashion, right? So first case la r, அடுத்த கேஸ்ல y is now maximum and b is now maximum. So now there is a magnetic flux is now moving, that overall that's மூணுமே electromagnet தான், பட் அதோட இண்டிவிஜுவல் கான்ட்ரிபியூஷன் பாத்தீங்கன்னா 120 டிகிரில சேஞ்ச் ஆயிட்டே இருக்கு. ஒரு 120 டிகிரில ஒன்னு r மேக்ஸிமா இருக்கு, அடுத்த 120 டிகிரில y மேக்ஸிமா இருக்கு, அடுத்த மேக்ஸிமம். ஓவரால் ரிசல்டன்ட் ஃப்ளக்ஸ் லைன்ஸோட குவான்டிட்டி ஒரு செகண்ட்ல இந்த பக்கம் இருக்கு, அடுத்த செகண்ட் இந்த பக்கம் இருக்கு, அடுத்த செகண்ட் இப்படி இருக்கு. ஸோ the overall resultant EMF, that is called overall resultant electromagnetic force, is now continuously rotating, right? So this is called RMF. This is called RMF. So rotating magnetic field is now generated. How the rotating magnetic field is rotated? Because of my three-phase AC power supply is now apart from 120 degree, so the power supply is also continuously changing with respect to time. So there is a rotating magnetic field. This is set up. Right now, என்ன பண்ண போறேன்? This magnetic flux lines is continuously rotating, right? So அப்ப உள்ள இருக்கிற காயில் இருக்கு இல்லையா, இந்த காயில் is now closed path. So now there is a one more case is now Faraday's induction law. The coil is now closed path. The flux lines is now continuously changing, right? Continuously changing. But now there is a one more EMF is going to be built upon this closed path circuit, which is already we are immersed in this in between magnetic flux lines. But there is a EMF is going to be generated because d phi dt is changing now. Resultant flux inga irundhuchu, அடுத்த கேஸ்ல y க்கு வந்துருச்சு, அடுத்த கேஸ்ல b க்கு வந்துருச்சு. Now d phi by dt is changing totally with respect to this conductor, closed path conductor. அப்ப EMF is going to be built it up, and this is also short circuit conductor. I told that this is called closed path. But definitely there is a current flow is also going to be induced. Due to current flow in this coil, there is a one more flux line is also going to build it up. Up in the flux line, so in a rotating magnetic field now interacting each other. Now the rotor is going to be rotated. So this is what my three-phase induction motor is now. How start running, right? So this is the answer. These are AC three-phase motor working principle and as well as construction, right? So எப்படி rotate ஆச்சு? Due to RMF. So RMF எப்படி create ஆச்சு? Because of three-phase AC power supply. So due to three-phase power supply in nature, so there is a rotating magnetic field is also creating. This rotating magnetic field is now going to be set one more EMF on my closed path conductor, which is already I immersed in this field area. Definitely there is a magnetic induction principle. Due to that, there is a EMF is also going to be built upon by this secondary coil, which is already placed here. Now we are made it as a closed path. I already told that it's a closed circuit. Up a closed circuit, due to EMF, there is a current is now started to flow. Once the current is started to flow through this conductor, definitely there is a flux line is going to be generated. That is called a secondary flux lines. That secondary flux lines is now interacted with my rotating armature field. Now both are interacting each other. There is a one more field already is now rotating. That is called RMF. There is a one more flux line is also going to be built on my rotatory part. these two flux lines is now interacting each other. Now repulsion and upulsion force is now going to be created. Now the rotor is now start to running. So this is why the three-phase motor is now start to running, right? So it's very quite interesting, right? So without any power supply is externally given, the rotor is now start rotating. This is why it's called, there is an induced EMF is going to be build it up, right? So there is an induced EMF is going to be build it up on my secondary part. That is why it's called induced EMF. Due to this induced EMF only the current is flowing and the rotor is start rotating. Due to this induced concept, this in AC motor is also called as induction motor. Always they will call induction motor. But in AC motor, we are giving a power supply to rotor side. That's why the conductivity property is coming, right? That's why DC motor is also called as conduction motor. DC motor is also called as conduction motor. AC motor is always called as induction motor, right? So this is a point I'm just going to link it to you, and we'll see later. So tomorrow we're just going to go with it single phase induction motor, right? So thanks for listening. I think I crossed 2 minutes, right? So thanks for patient, right? So this is why the AC motor is going to be running. So anyway, I'm just going to record it this session. I'm just going to right through you later, right? So thanks for listening, thanks for attending as well as, right? So we'll see tomorrow classes, right? Thank you all.
தேங்க்யூ சார்.
கொஞ்சம் ஃபாஸ்ட்டாக போயிட்டுனா வேறு வழி இல்லை. ஆனால் புரிஞ்சிருக்கும் கண்டிப்பாக இண்டஸ்ட்ரி ஈஸியாக தான் இருக்கும், ரைட்? நோ டிஃபிகல்ட் இன் திஸ், ரைட்? தேங்க்ஸ் ஃபார் லிசனிங் அண்ட் ஜாயினிங், ரைட்?